So in the last video we started to see that there was a correlation between the left and right movement and the up and down with our h and our k value, and we already know that because we've dealt with this type of vertex formula type setup with our linear and our absolute value and our exponential equations as well. And so we've seen this before, and so just a reminder, we're going to go through the notes very quickly, and we're going to see that h is the horizontal shift. Okay, we remember that. So a positive number here shifts it left, and a negative number moves it right. Okay, then k, of course, is the vertical, and that's what we just talked about in the last video. We could see that change. Positive shifts up and negative shifts left. Okay, if a is negative, a, remember, is that scale value that's outside of the parentheses. If it is negative, then the function has been reflected across the x-axis. It means that we just flipped it upside down. Okay, we flipped it from going this direction over the x-axis so that now it would be going down. All right, and if the absolute value of a, so that number, if that number out there is greater than 0, not even thinking about that positive or negative, we're talking about absolute value here. So if it's 2, if it's anything greater than 1, even if it's negative 2, that number without the, we're not looking at the positive or negative, is greater than 1, then it's going to represent a vertical stretch. Okay, meaning it's going to change the scale of it. And then if it's less than 1 but greater than 0, so a fraction, if it's a fraction, then it's going to represent a vertical compression. Okay, and we're going to look at what that looks like. We'll see an example of that in just a second. Okay, so I'm going to go up 1 right here, and we're just going to do a quick example so that you can see some of these translations in play now that we've talked about them. So here we have an h value. Okay, remember that our h value is 3. Okay, that's our 3 right here. And our k value is a -2. Okay, 3 and -2. So we're going to plug those in. We have 3 and -2. And then we are going to check our calculators, and we're going to plug this in. So we're going to do 1/2. Okay, remember I like to keep our fractions in parentheses, and it's actually a -1/2, so let me just start over. Alright, so -1/2, and then we have x minus 3 raised to the 2nd power. I have deleted the whole thing again. I'm so sorry, guys. Bear with me. It's hard to do it. I had it turned sideways. So we have x minus 3 squared, and then we have -2. Alright, so now I think I've got it. Alright, so here is our, apologize for that, here is our graph. So we knew that our vertex point is at 3, -2, so if we look surrounding that, if we go to 2, we have -2.5. If we go to 1, we have -4. If we go down from that, we have 4, -2.5, and 5, we have a y value of -4. Okay, so we got all that plugged in. So let's go ahead and graph that and look to see what it looks like. So we are going to do 1, -4, 2, -2.5, 3, -2, 4, -2.5, and 5, -4. Okay, so here is our new parabola. Okay, if you notice that it has moved down 2, my apologies, it has moved to the right 3, it's been flipped, and it's also wider. Notice that we go instead of going over 1 up 1, we actually go over 1 and down a half. So it's actually wider, and we would call that compressed. Meaning I took that U shape, and when I vertically compressed it, I pushed it down, it got wider. Okay, so that's what a compression looks like. So I just wanted you to see an example of what that looks like.